You're using AWS Lambda, serverless computing, completely abstracted. You don't manage servers, you don't think about infrastructure, you just upload code and it runs. Beautiful abstraction. Then you notice the first invocation of your function after it's been idle takes 800 milliseconds, subsequent invocations take 50 milliseconds. What's happening? Cold starts. Your function isn't instantly available. It's being loaded into a container on a physical server somewhere. The abstraction said serverless. Reality says server with initialization time you can't control. That's abstraction leakage. The implementation details that were supposed to stay hidden are bleeding through and affecting your application's performance. The abstraction didn't eliminate complexity, it just concealed it. And now that concealed complexity is visible in your metrics, frustrating your users and requiring you to understand the very infrastructure you thought you'd abstracted away. Let's talk about how and why cloud abstractions leak. Abstraction leakage occurs when implementation details from a hidden layer become visible or impact behavior at the abstraction layer, forcing users to understand and account for complexity the abstraction was supposed to hide. This concept comes from the law of leaky abstractions, formulated by Joel Spolsky, which states that all non-trivial abstractions, to some degree, are leaky. You can't perfectly hide underlying complexity. Eventually, some detail escapes, and users must confront it. In cloud computing, leakage manifests when the abstraction's behavior is influenced by hidden implementation in ways you can observe. That Lambda cold start is leakage. You're not supposed to think about containers, but container initialization time affects your abstraction. Error messages, or system behavior, reveal what's underneath. An error message that says MySQL connection timeout when you're using RDS database reveals that RDS is running MySQL under the hood. Performance characteristics expose underlying infrastructure. Latency between regions reveals physical distance and network topology. The abstraction claimed to hide. Limitations in the abstraction reflect constraints in the hidden implementation. API rate limits reveal control plane architecture. Storage IOPS limits reveal disk subsystem realities. The critical insight: abstractions don't eliminate complexity, they relocate it. And relocated complexity has a tendency to leak back through. Let's examine specific ways cloud abstractions leak in practice. Network latency leaks physical reality. Cloud abstractions present everything as just network calls. But latency between US East and Asia Pacific reveals that data centers are physically thousands of miles apart, separated by oceans and routing infrastructure. The abstraction can't hide physics. When you're building globally distributed systems, this leakage forces you to understand physical topology you thought was abstracted. Noisy neighbor problems leak multi-tenancy details. The abstraction says you have dedicated virtual resources. Reality: you're on shared physical hardware. When another customer's VM on the same host starts consuming massive CPU, your performance degrades. The abstraction leaked. You're forced to understand that dedicated virtual resources run on shared physical infrastructure with contention you can't control. Error messages leak underlying technologies. You're using a managed service with a clean abstraction. Then, an error occurs. Post-BGP connection pool exhausted, or underlying DynamoDB table throttled. These messages reveal implementation technologies the abstraction was hiding. Now you need Postgres expertise or DynamoDB knowledge to troubleshoot a service that claimed to abstract those details away. Cold starts leak container architecture. Serverless abstractions claim you don't think about servers. But cold start latency reveals there are containers being created, loaded, and initialized. Warm instances reveal there's state preservation and reuse happening. The serverless abstraction leaks server-full implementation details that affect your application design. Storage consistency models leak distributed system realities. S3 abstracts away the complexity of distributed storage, but its eventual consistency model leaks the reality that your data is replicated across multiple systems that take time to synchronize. You write an object, immediately read it from a different location, and it's not there yet. The abstraction can't hide distributed systems physics. Maintenance windows leak physical infrastructure. Your RDS instance has required maintenance windows. Why? Because there's physical hardware underneath that needs patching, updating, or migrating. The managed database abstraction leaks the reality that it's running on physical systems that require maintenance you thought you'd abstracted away. API rate limits leak control plane architecture. Clean APIs abstract away infrastructure complexity, but rate limits, 10,000 requests per second, 100 concurrent operations leak implementation details about the control plane's capacity, database backends, and architectural constraints. The abstraction's limits expose the hidden systems limits. Performance tiers leak storage architecture, provisioned IOPS, general purpose, throughput optimized. These options leak that different storage media with different performance characteristics exist underneath. The simple cloud storage abstraction leaks hardware realities, SSDs versus HDDs, NVMe versus SATA, different controller architectures. Regional availability leaks business and infrastructure realities. Not all services are available in all regions. This leaks that physical data centers have different capabilities, that regulatory constraints exist, that provider expansion is uneven. The abstraction of global cloud leaks the reality of specific physical locations with specific constraints. Cross-service dependencies leak during outages. Services presented as independent suddenly fail together. Why? Hidden dependencies. DynamoDB depends on internal authentication services, monitoring systems, and management infrastructure. When those fail, DynamoDB fails, leaking that the abstraction of independent services conceals a complex web of internal dependencies. So why can't providers build abstractions that don't leak? Because perfect abstraction is impossible. Physics can't be abstracted. Network latency is bounded by the speed of light. Storage performance is bounded by physical media characteristics. Compute is bounded by transistor physics. Abstractions can hide these realities temporarily, but they can't eliminate them. Eventually, physical limits manifest as abstraction behavior. Trade-offs must be exposed. Every implementation makes trade-offs: speed versus consistency, cost versus performance, simplicity versus flexibility. These trade-offs inevitably leak because users need to make choices that align with their requirements. The abstraction can't make those choices for you without exposing the underlying options. Edge cases reveal implementation. Abstractions work well for common use cases. That's what they're designed for. Edge cases stress the abstraction and expose underlying implementation. High traffic reveals concurrency limits. Unusual data patterns reveal caching strategies. Extreme scale reveals architectural bottlenecks. Failures expose hidden layers. When everything works, abstractions hold. When things fail, you see through them. An outage reveals dependencies. An error reveals underlying technologies. A performance degradation reveals resource sharing. Failure is the ultimate abstraction leak. Cost models leak implementation. Pricing reveals what's actually expensive for the provider. Egress charges leak that data transfer has real costs. Storage pricing tiers leak that different media have different economics. Per request pricing leaks that there's actual computation happening per request. You can't hide implementation cost structure without arbitrary pricing, which creates its own problems. And fundamentally, you can't abstract away complexity you don't understand. Some complexity is inherent to distributed systems, networking, storage, and computation. It can be hidden for simple cases, but it inevitably emerges in advanced use cases. So how do you work effectively when all abstractions inevitably leak? Expect leakage and plan for it. Don't assume abstractions are perfect. When designing systems, anticipate that implementation details will occasionally matter. Build in flexibility to adapt when leakage occurs. Learn enough about what's underneath. You don't need to become an expert in everything the abstraction hides, but understanding the basics helps you recognize leakage when it happens. Know that Lambda uses containers. Know that RDS runs actual database engines. Know that regions are physical data centers. Surface-level knowledge of hidden layers helps you interpret leakage. Design for abstraction failures. When the abstraction leaks during incidents, what's your fallback? Can you work around cold starts? Can you handle eventual consistency? Can you tolerate noisy neighbor impacts? Build resilience that accounts for implementation realities leaking through. Use leakage as diagnostic information. When abstractions leak, they're revealing information about underlying systems. Error messages that leak implementation details can guide troubleshooting. Performance characteristics that reveal hardware can inform optimization. Leakage is annoying, but it's also useful data. Choose abstractions based on acceptable leakage. Some abstractions leak more than others. Evaluate whether the leakage you'll encounter is acceptable for your use case. If cold starts are unacceptable, serverless might not be the right abstraction for that workload. And most importantly, don't fight leakage, adapt to it. Abstractions will leak, complexity will emerge. Accept this reality and build systems that work with leaky abstractions rather than assuming perfect hiding. Abstraction leakage is inevitable. Every cloud abstraction hides complexity that will eventually become visible, affecting your applications in ways you didn't expect. Network latency, cold starts, noisy neighbors, error messages, performance limits, all reveal that the simple interface sits atop complex reality. The law of leaky abstractions applies everywhere in cloud computing. You can't perfectly hide infrastructure complexity. The best you can do is understand where abstractions are likely to leak, recognize leakage when it happens, and design systems that remain functional when implementation details break through. And remember, the abstraction is working until suddenly it isn't. Plan for the leak. Thanks for watching.